section 12 in quotes, lesson 4. We're going to do the part 4. I think I split lesson 4 up into 2 days because it just got so darn big. So let's zip ahead to after the polynomial division. We're going to learn synthetic division in this video. So up on the top, that's what we just did, long division. Some of you have done this before and you're really good at it. That's great. Let's actually start by reviewing the the standard traditional long division. Let's do that. We're going to do a synthetic division. I'm betting a bunch of you have done this, but let's review it, or some of you are going to learn it for the first time today. So first complete this traditional long division so that we can compare the two side by side. So I'm hoping that's what you got. Check your opposite signs, check your negatives, check whatever. Check your adding. It's really easy to bring down. You can see right here, for my first time through, I made that a positive 16 when it's a negative 16. Any dropping of a little thing will completely change what happens. But you can see we do have a factor here. X plus 2 is a factor of x cubed minus 3x squared minus 16x minus 12. So synthetic division is used whenever we divide by x minus a. It's actually, and this is x plus 2, so it's x minus negative 2. So the idea is when you look at this, there's a lot of times you're rewriting numbers. Think about how we rewrote the 5x squared there. We rewrote the, we rewrote the 6s. There's a lot of rewriting that is inefficient. We're also seeing lots and lots of use of the variables. So there is a shortcut. And this shortcut we call synthetic division. So I'm going to take the a value, always the opposite of this. So this is going to be negative 2, and I'm going to put it in a house. I like talking about it being in a house. And then I just write the coefficients of the polynomial. So in this case, I've got 1x cubed minus 3x squared minus 16x minus 12. And notice I'm not writing any x's. That if I have 4 terms, I know that it's a cubic. So there's some understanding that goes on here. If I'm using synthetic division, I'm dividing by a polynomial and that the powers decrease by 1. So you would have to be sure you substitute in. If it's missing a term, you need to substitute in a 0 or put a 0 in there. So the process is similar. Now notice because of this opposite, we're going to be adding instead of subtracting. So let's do some parallels along the way. So I'll first start by bringing down the 1, and then I multiply. Negative 2 times 1 gives me negative 2. So this part is multiply. And then here I want to add. Is there a number that's similar there? That negative 5 popped up right here. That's the same negative 5 as we're seeing here. Now I want to multiply. Negative 2 times negative 5 gives me positive 10. That positive 10 is very familiar as well, isn't it? Did we see that somewhere? Right there. Minus negative 10 is a positive 10. Now I'm going to add, and that's where this negative 6 is down here. So it's a direct parallel. Negative 6 times negative 2 is positive 12. And you can see I usually like putting a double line there. Some people put a 0, and that's fine. So now I need to understand what this means. This negative 2 means we're talking about dividing by x minus negative 2 or x plus 2. This expression up here was x cubed minus 3x squared, right? And so forth. So this is 1, 2, 3 terms. It's going to start with x squared. You can also think in terms of if we're dividing by a cubed, a single by a cubed, this is going to be x squared minus 5x. The powers go down by 1 minus 6. A lot less writing, exactly the same meaning. What's really interesting, see I've written my multiplication statement. This has to be equal to the x cubed plus yada yada yada. Like that, yada yada yada. Okay. So, but we can continue to factor. If I have a quadratic that's factorable, I can factor that sucker. I can say, and this is one that's really tricky. If that's a minus, I want to be sure that I set this up like so, with a plus and a minus. This one, a lot of people are drawn to the 2 and the 3 multiplied to 6, but because that's a negative, one's got to be positive and one's got to be negative, so we're looking at minus 6 and plus 3. Ta-da! Let's go try another one. Let's just repeat the process. I'm going to get you started and see what you do. Remember, it's x minus a. So I'm going to take the positive 6 and put it in the house. And then I want the coefficients. Let me straighten it out a little bit. The coefficients of the term, and you'll find they're exactly the same. So go ahead, see if you can finish this. See, here's what this looked like, and I've drawn a little schematic. The pink means you multiply by the number in the house. The purple is where you add. Multiply, add. So then interpret this. What does this mean? What is the multiplication statement? There's the multiplication statement. And notice you can continue to factor this. So I wrote continue so that you could have a completely factored cubic. So basically the synthetic division is giving you a jump start on factoring a cubic. There's the complete factoring of the cubic. Let's add something to this. So let's say we have, it's a brand new function. If you're really savvy, you'll notice that, wow, that was the same function we were working with. Yeah, it was. So now we've got, given that x minus 3 is a factor of this polynomial. Now notice I'm not just giving you the expression, I'm giving it to you as a function. That p of x, that's an f at x notation. And it's saying to factor p of x, because then you're going to get some additional information that will really help you out. So given that x minus 3 is a factor it. Start by completing the synthetic division. If you want to do long division, you can, but you know what? Synthetic division is going to be so much shorter, and it's really going to be what you want to use. And we already showed that it's the same thing. So go ahead, put 3 in the house, take the coefficients of this, make sure you're in descending order, and complete the synthetic division. I hope that went well for you. Okay, and I continued to factor. Ooh, I left off a parentheses. Does that annoy you? Yeah, it should annoy you, because it would mean something completely different without the parentheses. So, so if I've got this as my polynomial, notice I plugged in the p of x. So there's my multiplication statement. Actually, I know that this function is also equal to what was given up here. So now what are the x-intercepts? These x-intercepts are called roots. You might find x-intercepts, roots, zeros. There's a whole bunch of words. So you know if there's a whole bunch of vocabulary words for something, it's going to be important. So what are the x-intercepts? X-intercepts are where y equals 0. So you're going to set the y value equal to 0. 0 equals x minus 3, x plus 2, and x minus 2. So if I want to solve that, I know I've got 3 things multiplied together to be 0. So by the MPOS, multiplication property of 0. Is that what you guys call it? Okay. Then we know either x minus 3 equals 0, or x plus 2 equals 0, or x minus 2 equals 0. So the x-intercepts are, you got 3 of them. So it's a cubic, and you've got 3 of them, are either 3, negative 2, or positive 2. Wow. So with that little jump start on what one factor was, or one really, that could tell us something about an x-intercept, couldn't it? We could find all the x-intercepts of this polynomial. The thing is now, I gave you the jump start of x minus 3 is a factor. What happens if you don't have that jump start? What do you do? Well, it used to be about a third of precalculus, and I'm not exaggerating, a third of precalculus was a whole set of tools and techniques and strategies for getting that initial start to determine what is one factor so you could find the others. We're going to use 2 techniques, one of which is kind of the foundation and one that was part of that 1/3 of the year of precalculus. But a lot of those ideas we just don't teach or use very much anymore. So let's go up here and say, okay, techniques using, if we want to factor, there's the techniques we're going to use right now so far. There's another one down the road. But techniques using division to factor. One, the rational root theorem, and the other is synthetic division. Been there, done that with synthetic division. Hopefully you're good at it. But the rational root theorem is a way of identifying possibilities for x-intercepts. And if you know an x-intercept, you know a factor. Like before, we saw if there's an x-intercept of 2, the factor was x minus 2. An x-intercept of 3 means the factor is x minus 3. So all possible rational roots are plus or minus factors of the last term over factors of the first term. Let's actually explore what this means. We'll list the possible rational roots, and then we'll see what we can do about that to jumpstart ourselves. So here's our example: 3x cubed plus 5x squared minus 26x plus 8. The possible rational roots, and I can symbolize these quite nicely by saying, okay, I'm going to take plus or minus factors of the last term, factors of 8 over factors of 3. So let's start by listing those factors. I'm going to say plus or minus, and I'm going to put a little squiggly because I'm going to talk about it as a set of numbers. We have 1, and I'm going to go in order from smallest to largest. 1, 2, not 3, 4, 5, 6, 7, 8. All over factors of 3. And there's like 2 factors of 3, 1 and 3. So I can actually list the possible rational roots. And so, so let's actually, looks like I've got 2 places to list them here, but let's say plus or minus, and I'm going to put outside the squiggle, and I'm going to take 1 over 1, 1 over 3, and then I'll take 2 over 1, 2 over 3, and I'm doing a permutation, I'm permuting it. 4 over 1, 4 over 3, and 8 over 1, or just call it 8, or 8 over 3. Those are the only things that are possibly rational roots of this function. So that's the first main step in jump-starting yourself to find what the possible roots are. The second thing to do, which we'll do, which we couldn't do 30 years ago, in the days before, actually it's more than 30 years ago, I'm showing my age. If we couldn't do it because we didn't have the calculators, check your calculator for realistic possibilities. So you want to plug this function, the 3x y equals, or p of x equals 3x cubed plus 5x squared minus 26x plus 8, into your calculator and look at where it appears, where that function, that curvy thing, appears to cross the x-axis. So you want to identify possible x-intercepts. So we're going to combine the rational root theorem, this list here, with what looks like might be x-intercepts on the graph of the function. So here I plug this in my calculator. I'm looking for the x-intercepts. Now if you're like me, you've been using your calculator for other stuff, and so your calculator might be set to weird windows. So you want to press Zoom Standard. That's the quickest and easiest way to set your calculator to a standard viewing window. I'm going to press Zoom. Do you see Standard there? Zoom 6. And it sets your window to x values of minus 10, positive 10, y values negative 10, positive 10. Kind of looks like I got a vertical line there. Do you see where this polynomial's got to go? Do you see where it is? We could expand. We want to keep our x values the same because it encompasses like all three possible values. It's a cubic, so the most you can factor it to is 3 terms. But let's make our y value a little larger and a little smaller. So I'm going to go to Window, so it'll help you see the whole shape. So I'm going to leave my x's the same. I'll go down to my y minimum. Let's make that a negative 20. And remember, you've got to press the negative and not the minus. And our, I put that in the wrong place. That would totally give me an error statement. Let's go y minimum should be negative 20, not minus 20, negative 20. And y maximum, we said we wanted to make that larger. Let's make it like 50. I'm guessing. You might try something else. We might look at this and say, I made it too big, or I didn't make it big enough. So now press graph. It's taking a long time, isn't it? I could have made it a little higher to have that maximum value in there. And does anybody know why there's a double barred line there? That's because my y scale was small enough and it's showing a whole bunch of those little ticks. So let's actually bother to go into Windows and adjust that. So I've made my y max 75 in the hopes it'll have that top bump and the maximum value. And I've also made y scale 10. So every 10 units it's going to put a slash, so you see fewer slashes. This x resolution is how accurately it's going to draw. If you increase that number, it'll go a little bit more quickly. I'm just going to leave it. And this video is going to be over. You have to stay in complete suspense for how this is going to turn out until the next video.